This is the rational root theorem. We've had 3 theorems so far. We had the remainder theorem, the factor theorem, and the rational root theorem. The rational root theorem, we first need to know what this means. So rational, okay, we're talking about numbers that can be written as fractions. Keyword being can. And the fractions have to be of 2 integers. Okay, and so what that means is we could have, like the number 3, that's a rational number because it can be written as a fraction of integers. 3 and 1 are both integers. Just regular fractions like 2/3, yeah, integer over integer, so 2/3 is rational. -4/5, that's rational. Even decimals are rational as long as they're finite or repeat, like 0.5, you can write that as 1/2. So this finds rational roots, and roots, remember, is a synonym for the zeros of the function, the solutions of the function, the roots, obviously, because they're using roots, and also the x-intercepts if we're talking about the graph. Okay, so this tells us what the possible rational, these numbers we can write as fractions, solutions are for a polynomial. And the way we do it, or come up with these list of rational or possible solutions, is we just look at the factors of the numerator over the factors of the, the factors of the constant term over the factors of the lead coefficient term. So let's look at this in practice, and then we'll see how to hopefully do this. So I've got the rational root theorem here written off to the right, and I've got a polynomial here, f of x they've called it. So it's function f, and it's got x's in it. That's what that notation means, and you can see the x's inside of the function right there. All right, so let's list all the possible rational roots, and I'm going to start with the color blue here because I'm going to be working on the p values first. They are the factors of the constant term. Your constant term should always be at the end, but it's the term that doesn't have any x's with it. It's just the number 12, a constant, always 12. And it says list the factors of 12, so things that divide into it. That's 2, and 3 goes into it, and 4 divides into it, and 6 divides into it, and 12 does. Next we'll do Q. Q, list all the factors of the lead coefficient. Lead coefficient is the coefficient that's in front. That's 10. So let's list all his factors. 1 goes into 10, 2 divides evenly, 5 goes into it, and I think 10 does. So those are all the possible factors, all the factors of P, all the factors of Q, and so here's what our possible solutions are. And I've got to put my blue one, the P, on top here, and my red one, the Q, just like the formula says, P over Q. And so I'm going to make this list straight up, and then I'll show you how they all simplify. So my first choice would be the blue one over the red one. My second choice could be the blue 1 over the red 2. My third choice could be the blue 1 over the red 5. And my last choice, if I use the 1, is a 1 over a 10. That's just with the 1. Then I'd have to do the positive blue 2 there, or plus minus 2. So I go plus 2 over my first red 1. Then I go plus 2 over my next choice, which is also a 2. Then I go 2 over 5. And lastly, I'll go 2 over 10. Okay, and I continue this. Next, I would do my 3 here. Oops, I meant to grab my highlighter there. So I do 3 over 1, 3 over 2, 3 over 5, 3 over 10, 4 over 1, 4 over 2, 4 over... You get the idea. Now what I'm going to do is write down this full comprehensive list, and I'm going to show you how you simplify these things and toss out one. So I'm not quite done with this. I jump screens. There we go. So this list does keep going. I just haven't completed all of it. So now I'm going to complete it all so you can see it. So I'll start back here at the beginning. And so when you have like 1 over 1, it just simplifies to a single plus or minus, and 1 divided by 1 is 1. Plus or minus 1 over plus or minus 2 just simplifies to a single plus or minus, so it's a half. There's plus or minus a fifth, plus or minus a tenth. 2 over 1 is just 2, so we just rewrite it as plus or minus 2. 2 over 2 here is again a 1, but we already have 1 in our list down over here. And so we don't have to put the 2 over 2 in because we've already got that covered. So I've done 2 over 1, 2 over 2 we didn't list, so now I do 2 over 5, then 2 over 10. So my 2 over 5, that just simplifies to 2/5. My 2 over 10 simplifies to 1/5, but I already have 1/5 in my list, so I don't need to repeat it again. All right, and I'm going to continue now on. You won't see the rest of these things. I'll simplify as I go. So I'm starting with the 3. So I go 3 over 1, 3 over 2, 3 over 5, and 3 over 10. Now those are repeats yet, so that's my 3's. Now I'm going to do my 4. 4 over 1, which is 4. 4 over 2, so I'm doing the 4 over the 2, but that's just 2 again. We already got 2 in the list. 4 over 5, I don't have him in my list yet, so I'll put plus or minus 4 over 5. 4 over 10 simplifies to 2/5, and so I already have that in here, so I don't have to do the 4 over 10. Or I do it, but I already have it. Next I'll do my 6, so I got 6 over 1. 6 over 2, which is 3, we don't need it, already have it. 6 over 5, we don't have yet. 6 over 10 simplifies to 3/5, and we have 3/5 already in our list. Now we got 1 left, I think, the 12 here, so we'll go 12 over 1. So we're minus 12. 12 over 2, which is 6. 12 over 5, we don't have yet. And 12 over 10 simplifies to 6/5. 12 over 10 is the same as 6 over 5, and we don't have it yet. So, list all the possible rational solutions. There's our possible list. And what that means is that if this polynomial has a rational solution, it's one of these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 of them, but they're all plus or minus. So 34 possible solutions. Some of these could be what this x is. Now these are just the possible rational roots. Maybe none of them work. Okay, but if it does have one, it's got to come from this list. Or if it has 2, they're both in this list. Or if all 4 of them, because this says 4 solutions, if all 4 of them are rational, they will all 4 be in this list somewhere down here. Okay, so let's look at the homework problems now, and I'll just rest. It keeps going. Oops. Through a few of them, you can see how simple they are. Now, this is just for this section 3 right here. Let's just list all the possible rational roots. And so I'll list my p's, factors of 12. 1, 2, 3, things that divide into 12, 4, 6, and 12. Factors for the lead coefficient. The lead coefficient is just 1, so that's 1. And so this one, as you're making your P over Q list, so when we go P over Q, it's going to always be 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 12 over 1. So we aren't going to write all that stuff. We'll just say, well, each of those simplifies back to whatever P is. So 1 over 1 is 1, 2 over 1 is 2. So we'll just say, yeah, your P over Q list is the same as your P list. Okay, so anytime that happens, you don't need to rewrite it. Just somehow indicate, hey, my P list includes everybody. I'm not going to do B here. B is very similar. I'll do C just because it's only got 2 terms. But this, again, is still the constant. There's no variable with it. So your P is either a 1, or it is a 1, 3, or a 9. Your Q is the lead coefficient, his factors, but that's just 1 again. So once again, P over Q is just going to be equal to your P list. Now let's look at one. Now we'll do two. I'll do one here. Let's do E. You can do the others on your own. Here's our P list. Again, looking at the constant term. Here's our Q list, looking at the lead coefficient. And then here is our possible rational solutions. Could be 1 over 1, which is 1. It could be 1 over 3, which is 1/3. It could be 2 over 1, which is 2. Or it could be 2 over 3, which is 2/3. And so there's the possible rational solutions. And that's it. Okay, and then in another video, I'll show you how to do problems in type 4 here.